Hello everyone, today in this video we'll be discussing the module 4 of cloud computing, and in this module we have about the cloud security. Some concepts are there. Make sure you watch this video till the end so that easily you can score more than 80% marks. I'll be discussing the most important questions from the exam point of view. And before starting, please do like and subscribe. It helps me make more videos like this, and if you have any questions you can DM me here. Okay, so without wasting more time, let's get started. So I'll be covering all the topics which you need to know from the exam point of view. The first topic is top concerns for cloud users security. Okay, now so the trend is that whatever the company is there and whoever is using the computers, they are transferring the data to the cloud, but it is not that safe. Okay, cloud also has some security issues that we'll be discussing. Okay, we think that once all the data is moved to the cloud, okay, all the data which is there, if it is moved to the cloud, it is in safe and secure, but it is not true. Why? Because first reason is false sense of security. The belief that cloud providers handle all the security can lead to neglect of critical risk, because cloud providers do not handle all the security. Okay, and loss of control. Once we have given the data, the users lose the direct control over the data. Unauthorized access and insider threats can also happen. Means someone external can attack to the cloud and take your data. Okay, and data storage vulnerabilities. The data which is there that could be exposed during processing and deletion, backup process are not transparent. Lack of standardization. No uniform rules are present, which due to which the processing happens. There are no rules present. Okay, it just happens. Okay, and legal and jurisdiction issues. Data may be stored across multiple countries. Okay, the servers which are there, that might be across multiple countries, so that the nearest to which country you are, it will be taken from that place. Okay, so that's why they keep in different countries, but different countries means different rules. We don't know, with unclear applicable rules, what will be the protection of the data. Okay, and multi-tenancy risks. Shared infrastructure can lead to large scale breaches. Okay, and future technology risks. Emerging systems like autonomous computing may introduce unpredictable security issues. As the technology rises, the hackers also use the technology to hack our systems, right? So it is a risk. Outsourcing chain risks. Limited audibility and compliance means we are not aware of what's happening in the behind the scenes because of some policies. We don't know what they are doing with our data, right? So these are the things which are happening. 10 things are there. Okay, any five you can remember from the exam point of view. And to minimize the risk, the contract between the user and the cloud service provider, CSP means cloud service provider, the user and the cloud service provider, there should be some agreement. What should be the agreement? Obligations to handle sensitive information and its obligation to comply with the privacy laws. Liabilities for mishandling the sensitive information or data loss, they should be paying the price for it. The rules for governing the ownership of the data, specifying geographical location where your data is stored and where it can be stored. Okay, and there are multiple ways in which the cloud security becomes risky. Okay, few more things are traditional security threats. Why cloud security can become risky? It can happen at the user side. Some other fake email can come, a spam email can come, and you click on it and your data will be accessible by them. Authentication and authorization is not up to that level. Distributed denial of service. Many hackers try to access your data at once and the system gets hanged. Phishing, that is making you fool and you will be clicking the link and they'll be able to access it. SQL injection means some script they will be writing and you'll be downloading that file in the name of some other song or something, and that will not be a song, it will be actually a hacker script, and your data will be gone to them. Cross-site scripting, from the different sites they will be attacking and attacking on the virtual machines also. So these are some of the traditional methods which are used for hacking. Okay, so traditional security threats are there. Same goes for the cloud data as well. So if your data is stored in the cloud also, these same things can happen there also. Availability of cloud services. Cloud services may not be always available. Okay, system can fail, power outages can happen, and even an earthquake or something else can happen which could shut down the cloud services for long period of time, and you'll not be able to access also them. Once cloud is gone, you will not be able to access because entire data of yours is stored in the cloud without any backup, right? And third party control, there will be third party people who are using, you don't know who is using, there is lack of transparency present, right? And storing of proprietary data, your important data which is there, that could be leaked to the hackers. Okay, and privacy issues also there, they are using your data without asking you. Okay, and broken authentication, people without authentication can also access your data if there is any breakage in that. Hacked interfaces and APIs can also be used if they are not secure. Permanent data loss, the hackers can delete your data forever. Then what you will do, your data is gone in the cloud, it will be there and the hacker will go and delete your data. Okay, so these are the risks, few more risks. Okay, what is related to the cloud security. Now next topic is the privacy and privacy impact assessment. What is privacy? Privacy means something not to be disclosed. What is personal to you, private to you, that has to be not to be disclosed to the whole world, that is called as privacy. There are laws preventing the usage of users data without consent, but they are not fully followed by all websites, as we all are aware of it. Whatever we try to Means if we make a search in a Google about some shoes and we open Instagram or Facebook, they will be seeing the shoes ads and all, right? So it's very clear that our data is being sold to other companies, okay, without our consent. And the main aspects of cloud privacy are lack of users control. We cannot control what data is there, potential unauthorized secondary use, that is using for ads, and data proliferation and dynamic provisioning. Okay, all websites should follow the four practices to ensure that the user's data is secure. Okay, notice should be there. If any data is going to be used for some other purposes, there should be a notice and we should be given a choice whether we are allowing it or not. Okay, that's the second point. And the third point is access should be given. Whatever the information is being collected, that should be accessible to us whether we want to continue it or not. Okay, and if we want to delete that information, we should be able to delete it. It's not that we give to the cloud and cloud can do whatever they want. And security should be there. Whatever data is being used, it should be secure. It should not be applicable to everything and everyone. It will become public like that. It should not happen. And we have some tools, privacy impact assessment tools, that will be carried out, that should be carried out in all websites to ensure that whatever the data is being used is legal to use, okay, with our consent. Next topic is cloud data encryption. You know what is encryption? Encryption means, suppose I have written A. For A I have assigned a symbol like this, and B I have assigned a symbol like this. For C I have assigned a symbol like this. So if I want to write ABC, I'll write this. Now if you show this to some random person, will they able to read it what it is? No. Why? Because this data is encrypted. Changing the symbols to some other symbols so that it is unreadable and unknown is called as encryption. Now cloud data is also encrypted, because if it is not encrypted, hackers can see what the data is. So even if the hacker get the data like this, okay, this is of no use because hacker doesn't know what each symbol means. So it is encrypted data. Now the thing is, encrypted data is secure, but to perform operations on it, to process it, to make a copy of it, or change the data, or do some algorithms on it, that is very hard. Okay, we cannot do the same algorithms on symbol data as we do with the plain text data, and it takes a lot of time. For example, if you want to do some operations on the encrypted data, it takes 6 minutes. If you do it on the plain text, it will just take 1 or 2 seconds. Okay, so that much difference is there as of now. And the dream of the scientists and the researchers is that to get a homomorphic encryption. In this type of encryption, the encrypted data will also take 1 or 2 seconds only. Okay, but this is not existing as of now. It's just a theoretical concept. Okay, in that there will be the following diagram and the formulas used, but it is not in reality. Okay, it's just a concept as of now. And there's another encryption which is order preserving encryption. Also it does the same thing but with a different formula. Okay, next topic is security of database services. Okay, database can also be given as a service. See, database is present there. Someone has a lot of data, they can provide the data for rent so that they can use some data, the people who want it, and they can pay a price for it. That is called as database as a service. It involves several group of entities. It's not that simple. The database owner, they will be giving the data to the user. No, data owner will be there, users of data will be there, cloud service provider will be there, because due to cloud only you will be able to connect with the database and the user, right? And third party agents will be there to handle the cloud services, and third party auditors will be there to handle whatever is happening with the data, whatever the operations are being sent forward and back, that backup will be kept by the auditors, right? So these many people are involved. When these many people are involved, it will become very less secure, right? The absence of authentication, authorization, and accounting controls, or poor key management for encryption or decryption, leads to hacking of database services. Malicious external attackers use spoofing, sniffing, man in the middle attack, side channeling, and illegal transactions to perform DOS attack, denial of service attack. If you have a system which only handles 10 users, 10 hackers can come and try to ping all the systems, right? So what will happen, your system will be hanged. If any genuine users come, they will not be able to access. Why? Because hackers are accessing it and depleting the resources. That is called as denial of service attack. Okay, man in the middle attack, between two transactions a man comes in the middle and changes the data and sends the hacked data to the other person and takes the correct data and leaves the scenario. So that is the man in the middle attack. Like that, attacks can happen in the cloud as well during the database connection to the database, right? From the user to the database. Movement between the databases could also be breached. One database is here, one database is here, moving the data in between. What happened? Hacker came and took your data. Here what came? Here zero came, nothing came. Here all the data is with the hacker, 100% data. Okay, so that is the movement between databases could be breached. Okay, in summary, data availability is affected by several threats: resource exhaustion, many hackers try to access the site; failures of consistency management; and failure of monitoring and auditing system. Because of all this, the hackers can make use of your system very efficiently. Okay, Next is the operating system security. Okay, previously we discussed the database security. Now it is about the operating system. What is an operating system? In the computer, whatever you are going to perform operation, that is handled by the system that is called as operating system. If operating system is there, then only all the software operations you will be able to handle. Okay, so OS allows multiple applications to run on the single system, and OS can also become a victim of malicious attacks, tampering with executable code and spoofing. Someone gave you a virus code in your USB saying that give me this game, but in their USB it was a virus was there, and that virus came and sat in your system. Now in the OS that virus has been attached with and you are not aware of it, but there is some background process going on. That person who is the clever person, he is able to see whatever you are doing on computer, right? So that is what virus is, and it OS can also be affected by virus. Access control policies specify how OS controls access to different systems. Okay, there should be policies which should be enforced so that the no virus can be able to take over your system. Every access should be made as low as possible, okay, with the lowest privileges required. If it is just to copy a game from one system to a USB, only the privilege for copying should be given, not to execute some other files in your system. That should be disabled. Okay, so the access should be as low as possible. Whatever is the requirement, that much only take and go from there. Okay, mandatory security should be enforced. Windows NT, this was a system which used to access privilege inherited from the main system. Okay, see, what used to happen is in the main system there will be access for doing everything. If any small folder comes here, that folder will also be getting the access for performing all the things. Okay, the inheritance happens where the permissions for the whole system, that same permissions will be given for the USB also, so USB is able to perform all the other operations. This is the thing which the previous system which Windows NT used to allow, due to which the access was gained to the illegal systems and the data used to be hacked. Okay, malicious software could be there impersonating trusted path and gain access to resources. There will be a game called Subway Surfers. Your friend will say, I have hacked version of Subway Surfer, you can gain unlimited money in that, and he gives you a USB and you put that USB in your system, but inside the Subway Surfer when you open it will be written hacked, right? So your computer will be hacked, and that was not your Subway Surfer game, it was a hacking game. Okay, so that will be a malicious software in the mask of a trusted path. Okay, that is also another security threat. Next is virtual machine security. What is virtual machine? Your machine is the one which you are using locally. If you want to use a machine which is present in your friend's home, so that is, if you are able to use that system here, that is called as virtual machine. How will you use that? All the data which is present here, that is being transferred live via the internet. Okay, and you will be able to see whatever is in their system in your system. Okay, that is the virtual machine. So hypervisor handles all those things, the connection to that machine, to allocating the resources of that machine, and using whatever the things are present there which you are allowed to use. So all those things are handled by hypervisor. Okay, it's like a manager. So hypervisor will be facilitating the use of your friend system in your system. Okay, now it controls the execution of privileged operations and can thus enforce memory isolation as well as disk or network access. To make it more secure, there will be a security layer. Okay, now this is the diagram of the virtual machine. There will be a guest VM and the guest OS. In between you have the application, and the security layers will be here. Okay, and the front end security layers will be here, and this is the back end security layers. Now there is a possibility to secure VM is to have the guest VM files sent to a dedicated VM. Okay, so if your friend is planning to hack your system, and in the name of virtual machine the friend is hacking your system, so what you can do is you can put your files in another dedicated VM, so that even if the friend hacks, you will not be losing all the files, you will be having a backup here. That is what is called a possibility to secure a VM, is to have a guest VM files to a dedicated VM sending the files. Okay, hackers can attempt to access VM logging files and thus recover sensitive data. Okay, that is still possible. So in order to make it secure, we have to pay some price for it. Okay, like the higher hardware costs and the cost of developing hypervisors, overhead of virtualization, and several types of hypervisors based rate a starvation of resources. Unlimited means a lot of access requests will be sent to our VM so that the resources will be finished, and the side channel attacks like the malicious attacks, lack of proper isolation, limitation of packet inspection. Okay, and the handle high traffic. If high traffic comes, it will be hanged, and buffer overflow attacks. There are also several types of VM based threats. Development of rogue or insecure VM. The VMs which are not secure, anyone can access it. Okay, and presence of insecure or tampered VM images. The images which are not correct, which have the hacked data in it. Okay, so that was about the VMs. Next is about the security risk posed by shared images. What is an image? Image, suppose you have iPhone, okay? In your iPhone, you are using whatever you want, and in your Android, you want to transfer all the data. Like it should look like iPhone only. So you'll use a Docker so that that image of iPhone will be stored here, and from the Docker, you'll be transferring to your Android phone. So in the Android phone, you will be using iPhone, okay? So that is the shared image, okay? And Amazon provides the capability of producing and sharing the images using AMI, which is Amazon Machine Image. The procedure involves couple of steps to set up these things, but the main point here is that when this process was being done previously in old time, okay, means whenever it was created at that time, when it was done at that time, it was found many malwares were there, okay. So what were the vulnerabilities? 22% of the Linux EMS had credentials that allow remote access, means 22% of the unauthorized people, they will be able to access it. And it was found 100 passwords were leaked, 995 SSH keys were leaked, 90 cases with the both, okay. And the SSH keys or password were public to everyone. Password based login was no use of it, okay. And cloud init script shared the SSH host keys so that man in the middle attack happens. So the keys were sent from one point to another point, but a man came in the middle and took the keys and went. So the man can be able to access the data without any issue, okay. Unsolicited connections, okay. Syslog daemons and the other external servers and the logs, everything was hacked, okay. And difficult to distinguish between legitimate and malicious outbound connections. So connection is there, but we are not able to identify if it is the genuine connection or a hacker's connection. Malwares were the clam AV identified malwares in the AMIs. Trojan spy was the Trojan agent. Firefox password were hacked by the Trojan. Okay. And privacy risks were also there. Creators may unknowingly expose the keys, API keys, and history files. All of these, when it is exposed, hackers can easily track your system and log into a system and do whatever they want. Okay. And recovery of the deleted files can also be done by the hackers unless it is safely deleted using shred, scrub, zero free, or wipe. Okay. So these were some of the risks. And security risk posed by management OS, okay. Now OS, we discussed what are the security risks. Now this is about management OS, the thing which handles the OS, okay. In that, what are the security risks? So here we have a small hypervisor, okay. Hypervisor, already told you what it is. It is a thing which manages the connection between the VMs and the local system, okay. VM is here and local system is here. How they are getting connected and what data is being transferred, that is handled by hypervisor, okay. Now it might seem secure, but it is not secure, okay. There are many risks associated with that, especially at the dom 0 level, okay. Dom 0 means the basic level which controls everything. There some security risk can be there in the zen level, okay. So there will be many vulnerabilities which will be looking. The key securities in zen virtualization, okay. Vulnerabilities in dom 0 is, it is critical for management, but it is also having security weak point, okay. 21 out of 23 attacks targeted dom 0 services. Attacks include buffer overflows, allowing code execution. If hackers could execute, they can perform anything on your system, right? So this thing was being happened at the dom 0 level. And denial of service also happening, okay. And a malicious dom 0 can prevent the VM startup, modify guest OS kernels, alter memory page tables, access guest memory. These all things hackers can do, okay. And it was happening, okay, unless it was made secure. Runtime vulnerabilities can happen. It can expose virtual devices, network traffic will be there, even encrypted communication can be compromised. Zen store, which stores system state, is a major target for attacks. Malicious VMs can block Zen store, disrupting other VMs, okay. And proposed security enhancement, how can it be made more secure? Encryption should be done, okay. And virtual CPU registers should be used. Hypervisor should monitor and validate memory integrity. Second point is secure the guest VM and data communication by using the data remotely and by using restricted hypercalls. Enhance the hypervisor security with new hypercalls. Encrypt the virtual CPU state. Encrypt the memory page. Ensure freshness. So basically, make the encryption more better. Okay, this is the gist of it. Encryption should be made more better. The more better it is encrypted, the less hacking will be there. And trade-off will be there. If you want to increase the encryption, it will be 1.7x to 2.3x for VM creation. The time will increase 1.8 to 1.5, 1.7, 1.9. The time will be increasing, okay, if it is made more secure. So that decision has to be made by the people who are handling it. Next is XOAR, which is breaking the monolithic design of TCP. Okay, it is a better version of Zen design. Okay, so it is enhancing security by maintaining the functionality, ensuring transparency, tight control of privileges, minimizing interfaces of all the components, and eliminating sharing, reducing the opportunity of an attack targeting a system component. Okay, by using all this, it is performing better than Zen. Okay, and it has four types of components: permanent, self-destructing, restarted upon request, and restarted upon timer. Okay, so by using these 4 components, it will be performing the enhancement of security. Okay, and this is a diagram for it, you can go through it. Next we have the QEMO. QEMU handles the device emulation. This was related to the computers, okay. And if you want to do the same thing in your mobile to make mobile more secure, we'll be using QEMU. Okay, it is based on XOAR only. Here, the most privileged components are Bootstrapper and PCI back. Builder remains active, but it is minimal. Zen store is divided into two parts: Zen store logic and state. But another thing comes, which is builder. By these three components, we'll be able to handle the QEMU. Okay, and the security and isolation features, it is shared only with the guest VMs. Auditing is enhanced. You will be able to know which hacker has come and what he is doing. Rebooting ensures a good known state, but it's expensive. Instead, the XOAR uses copy on write snapshots, so a better functionality is present here, so it is more secure. And the conclusion is that it is minimizing the shared code, destroying unnecessary privileged components early, enforcing strict access control and auditing, and using efficient snapshot for secure known as good VM states. Okay, so by using these four things extra than Zen, it is performing better security than Zen. Okay, next is a trusted hypervisor. Terra is a trusted hypervisor designed to support both open box and closed box platforms. Okay, to make the system more secure. So what is open box? Traditional VMs which are there. Okay, closed box is the VM which we cannot inspect or modify by the platform owner. It is more secure. Okay, and it supports both type of it. Okay, and the application define their own software stack based on security needs. High security apps should be having less OS dependency, and low security apps can have more dependency on the OS. Okay, and information assurance means the information which is used, it is integrated, available, and confidential. And authenticity and non-replication should be there. Securing the data processing, storage, and transmission should be ensured. And the enhanced security capabilities, trusted path should be used, remote attestation should be used, no root access for the admin. Okay, and management and control, the management VM chosen by the platform owner handles whatever the limits they have set. Authorization should be the allocation of the resources. The management and control is also well handled here. Okay, and challenges are largely and poor written, security risks are there, and DMA, direct memory access attacks are there. The solution is restrict the driver to access sensitive data, use hardware level memory to protect it. Okay, and the conclusion is that Terra, the trusted hypervisor, offers the open box and the closed box, which is flexible and this is more secure. Custom security levels are there, used based on how much secure you want your application to be. Robust isolation, trusted communication path, and remote trust assurance. Defense against platform owners and malicious drivers. So we usually tend to trust the platform owners, but platform owners are not good people. Okay, they can hack your systems, you cannot trust them also. So Terra even gives us security against the platform owners itself. Okay, so it is even double secure. Okay, so this is the best one, Terra trusted hypervisor. Next is mobile devices and cloud security. How to make a mobile device more secure. Okay, now why we need the security for mobile device? Because confidentiality, we need to have our data protected. Integrity should be there, tampering of the data should not happen. Availability means whatever, whenever we want the data, it should be available. Non-reputation, prevent the denial of message origination, means the cloud should not become so busy that if you open your own mobile, you will not be able to see your data. Why? Because cloud is busy. That should not happen. Okay, mobile technology stack, hardware plus firmware should be handled, and security hardware should be handled. Why mobiles are more vulnerable? Because easy app installation, you'll just see one hack version of a game which you are trying to make score in, so you'll try to download that hack version, and what happens, your device will be hacked. Okay, instead of the playing the hack game, your device itself is hacked and you have to buy a new device. Next is frequent interaction with untrusted networks. If you go outside in the mall and you want to save your data, because you want to save the data and do something else in the night, right? So what you will be doing, you will be using the Wi-Fi and the cellular data which is present in the mall, and that is totally unsecure, because whatever you are using the data in the mall, the person, the security man who is sitting in the his cabin, he is able to see whatever you are going to search. Okay, so that is an insecure data, and he can also insert the systems and the application that can hack your system. Okay, so it's not secure. Regular data exchange with other system, you are sending and receiving the files and messages with the other systems. Weak authentication, you are just using a short passcode, your nicknames and all will be in the password. It's very easy to hack. Inadequate storage, encryption, your storage is not at all encrypted. Once your phone is open, everything is accessible. Location services enable targeted tracking attacks. You want to become advanced, right? You are a very modern person, so you on the GPS all the time. What happens? Everyone is tracking you and hacking you, right? Unique mobile security threats, mobile malware, data theft, and unauthorized access, electronic eavesdropping, location-based tracking, insecure third-party apps. Now, there are many risks like the infected files will be there, data leakage from your device can be lost or stolen, encrypted communications on public network, rooted or jailbroken that bypass security layers. You want to become very cool, right? That's why you jailbreak your own phone, and what happens? Security will be broken, and you'll be able to directly access some files. But what happens in behind the scenes? Hacker will be able to access your device. Okay, and malicious apps circumventing access control. So mobile device plays significantly major role in the attacks which is happening in the recent times. Okay, so there has to be specialized security measures to protect both the device and the cloud from breaches and data loss. Okay, one thing is you should not become so stupid that you'll be allowing all the hackers to access your phone. Second thing is cloud should be made more secure. Even if you do that stupidity, cloud should be able to handle it. Okay, so this is the main points from this topic. Next one is cloud security defense strategies. To solve the trust problems, a new data protection model is introduced. So in this model, there are three layers. First is whatever the data is there, that should be on-site security year round. Means it should be having biometric readers, CCTV should be there, motion detection, and man traps are often deployed. Second, network security demands fault-tolerant external firewalls. Third is platforms should have the security demands SSL and data decryption, strict password policies, and systems trust certification. Means whatever you're going to use, it should not be visible to the security guard. Okay, that is a system trust certification. So these are the different types of things used in the application and API level. It is made secure by binary analysis, scanners, and web app firewalls. In the data information, data loss protection, common log file, database activity monitoring. Management level, it is government risk management and compliance. Networking, we have the firewalls present, anti-DDoS systems. Trusted computing, we'll have the hardware, software, ROT, and API. So basically in all of the layers whichever are present in the cloud, that will be made secure by using the following technologies. Okay, then what is the security challenges in the VM? Hypervisor malware. The hypervisor itself can have some malwares, guest hopping, hijacking, or VM toolkits, and man in the middle attacks manipulating the kernel data structures. Okay, so these are some of the challenges, security challenges. So how do you make it more secure? By using the 8 methods given below. First is secure the data centers and computer buildings. So choose hazard free locations. Okay, don't choose a location in between a border. Okay, why? What happens if you choose a location and place your data center in between border of two enemy countries? What will happen? Some country will throw a bomb on it and it will be blasted. Okay, so your data will be lost. Don't choose that kind of locations. Okay, next is use redundant utilities at multiple sites. Okay, even if one is getting destroyed, there should be a backup at some other place. Okay, trust delegation and negotiation. Okay, there should be policies to have the trust certificate should be given. Worm containment and DDoS defenses. Even if DDoS happens, some worm will come and eat all the hackers. Okay, that functionality should be there. Internet worm containment and distributed defense to the data centers to make this data centers all secure should be there. Reputation system for the data centers. Reputation should be built very well, and fine grained control, access control to wherever level you want to control your data, you should be given the right. And copyright protection, piracy protection, and privacy protection. Okay, the company should not use your data for their own benefit. Okay, so by using these policies, we will be able to make our data more secure. Okay, VMs can be cloned, saved, encrypted, or moved with ease as software. This helps with defense virtualization. The following are the features in designed in a secure cloud. So if you imagine a secure cloud, how it will be? It will be dynamic web services with full support from secure web technologies. The technologies will be very secure. The trust will be established between users and providers. There will be effective user identity management. No one can fake your identity and access the system. Single sign-on and sign-off. Okay, every time you want to access something, you have to sign in. Okay, that will be more secure. Auditing should be there. Whatever someone is doing in the system, that should be logged somewhere, so that we'll be able to see what is happening in the behind the scenes. Okay, and shifting of control of data operations from the client environment to the cloud providers. Okay, protection of sensitive data. Okay, so here two layers are there. First is the gateway layer. Whatever the data is coming from here, it will pass through the gateway, then it passes through the firewall. So two layer security is present here. Okay, and it finally reaches the cloud. Distributed intrusion anomaly detection. Okay, intrusion or detection system means it should stop the attack from happening. Okay, that kind of systems. So how it does it? Basically, the hackers are there. These are the hackers. Okay, hackers, what they will do, they'll send all the data to one system, and one system will be hanged. So in between sending the data, there are many layers. In this layer, just cut off this layer so that data will not reach here only. So we can avoid it using that method. Okay, so these things do that only, the intrusion detection systems. Okay, if they observe a large data coming from here, they'll be able to stop it at some point. Okay, that is how they work, the intrusion detection systems. Next topic is data and software protection techniques. How can you protect your data? One method is to color the data. Okay, means if you have collected the data as red, okay, and in between one green packet has come. Okay, what does that mean? That means it is a hacker packet. It's not your packet. Okay, so that is also one very useful method where you can secure your data. Okay, and privacy protection software should be having the following features: special API should be there, fine grained access should be there, and shared data should be there. Means from the VM the data is coming, it is unencrypted, and if it is unencrypted, what happens? The man will come in the middle and hack the data, modify the data, and then send to the destination, which is the hacked data, right? So ability to secure the ISP should be there, personal firewall should be there, privacy policy and VPN should be connected. Okay. So this is a data coloring. If the data is of different color, then it is distinguishable that it is not our data, it is a hacker data. Okay. Once the data is moved to the cloud, users cannot easily access that data. Okay, this is another issue. If you have moved your data to the cloud, you cannot access your data and you don't know what's happening with your data. Okay, so that is called as data lock-in. It is attributed to two causes: lack of interoperability. Okay, each cloud vendor has its proprietary API that limits users to extract data once submitted. So once you submit your data, only 2 or 3 times you can access. If you want after that, you cannot access because it is against their rules, which says that it limits the users to extract the data. Okay, lack of application compatibility. In most computing clouds, if you submit a data from a Windows system, that data cannot be used in a Linux system. Like that it is. Okay, so that is also a useless rule. So to solve that problem, there is a solution to use standardized cloud APIs, in which you will be able to access how many ever times you want your data, and second is whichever data you send here, that will be applicable in all the other systems. Okay, next topic is reputation guided protection of data centers. Reputation means what? You are trusting that, okay, you know what it is. Okay, if you have a good reputation, means you have done something good which the people recognize for. So reputation is a public opinion. Using reputation, protection can be guaranteed. If there is a reputation for a particular system that it is useful, so you'll be trusting that system more, right? So to build reputation, the trust management, there are techniques for securing peer-to-peer and social networks that could be merged. Okay, so this is the diagram. The reputation system can be either centralized or distributed, and in both of them you can have user-oriented or data-based, center-based. So some of the reputed systems are eBay, and social network Google, Amazon, and Abra, and Peer Trust, Aegean Trust, VU, Power Trust. Okay, so these are the reputed social systems for the networks and the cloud platforms. Okay, now redesigning the reputation system for cloud instances. Okay, it involves uniquely naming the data to ensure global consistency. Okay, and the hierarchy of the P2P reputation system are suggested. Okay, and reputation should benefit both the cloud and the data centers. Okay, whatever the data you are going to use, it should be implementable, easier to implement, and it should be easier to use, and the security mechanism should be there. Present in the earlier can greatly access the reputation system. Okay, so if all these things are there, it is a good system. And if we see this diagrammatically, there is a trust overlay network present. Okay, which is having two layers. Okay, bottom layer and top layer, which will ensure that the data becomes more reputed. A distributed hash table is used to model the network. Okay, so two layers are there for fast reputation. In the bottom layer we have the trust overlay for distributed trust negotiation. At the top layer we have for fast virus worm recognition, signature generation, and dissemination for piracy detection. So these are the two layers present here. This is against the worms and the DDoS attack. This is the top layer, and this is the bottom layer, which reputation guarantees against the aggregation and probing of piracy colluders. Okay, in between we have the systems. So difference between piracy attacks is given from here, and reputation aggregation integration is given from here. So based on these two layers, the reputation will be increased. Okay. So this is all for the module 4 of cloud computing. And if you found this video helpful, please like and subscribe. It helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.